Whenever we're graphing parabolas, we want to get the equation into this generic form, where y equals a times the quantity x plus h squared plus k, where the a represents your amplitude and your vertex is h and k. So in this case, it's going to tell you exactly where your vertex is. That's why we put it in this formula, where your vertex is and how quickly it's going up. So your amplitude tells you the higher the number, the faster that parabola is going up. And so you're going to have a skinny parabola. The lower that number is, the fatter it's going to be. So if you, let's say that your A is 1/4, that's going to be a very wide parabola. It's going up very slowly. And so it gives you a pretty good idea. You could look at the equation and have a very good idea of what's happening with your parabola. Now, in order to get it into this position or into this equation, you're going to have to remember how to complete the square. So if you've not completed the square for a while, you may want to go back and watch the video on how to complete the square, because completing the square makes this very easy with any equation to get it into this form so you can see exactly what's happening with an equation. So let's say we have the equation y equals x squared minus 8x plus 5. To get it into this position, we're going to rewrite this as y equals x squared minus 8x. We're going to leave a spot to complete the square, and we're going to add our 5 out here. So we've not changed anything. We've just put in some parentheses just to make it easier to work with. Now, to complete the square, we're going to take half of this -8. That gives us -4. We're going to square it, and that gives us 16. Now, you can't just add in 16, so we're going to also subtract 16 out here, just so we've added 16 and subtracted 16. So really we've only added 0. We haven't changed anything about the equation other than the way it looks. So now we can rewrite this as x minus 4 quantity squared minus, because of this -16, minus 11. So y equals, and in this case, we don't have an a out here. In reality, we do. This is just 1 times x minus 4 quantity squared minus 11. Okay, so our vertex here is equal to, now I want to rewrite this because in our equation we have x minus h. So our h here is just 4. But our k, remember, our k here is positive, so we're going to bring this sign with us. Our k is -11. Okay, so our vertex is at the point 4, -11. And this is just going to be a standard parabola. It's just a normal rate of growth. So if we were to graph this, we would go to 4, -11. We'll put that down here, and it's just going to be kind of a standard parabola. Now, we obviously haven't put much time into what exactly that's looking like, and you can do that by just picking a couple of points, but it just gives you a pretty good visual representation of what's happening. Now, if we want to make this a little more complicated, let's put a 2 out here. Okay, so let's rewrite this now as y equals, let's add our parentheses, 2x squared minus 8x plus 5. Now, in order to complete the square, we need a 1 to be out here. So we're going to factor a 2 out of this. So y equals 2 times x squared minus 4x plus 5. Now we can complete the square with this. We can take half of that, which is -2. We can square that, and we can add a 4. Now, we've got to be careful here, because if we just we add a 4 here, normally we would subtract a 4 here, but the problem is we're not just adding 1 4. We've got 2 of them. So before we pull this out, we've actually added 8, so we need to subtract 8 here. That gives us y equals 2 times x minus 2 squared, and in this case now we have -3. So our vertex is going to be at the point. Remember, we're changing the sign here, so our x is 2, our y is -3. But this time we're going up a little bit faster because our A is 2. So if we were to graph this, we'd go to the point 2, -3, would say it's right here. But this time we're going to be a little bit skinnier in our graph, okay? So learn how to play around with this to get your equation to be in this form, because once in this form, you can visually in your head picture about what that's looking like. And if you need to get more of an exact idea of what it's looking like, put in a couple of points and you can tell exactly where your lines coming up are going to be. Now, one thing I need to add, if this is negative, let's say the A is negative here. Now that changes the equation here. We're not going to worry about that right now. But all that does to your amplitude's negative. So if your vertex is still right here, now your graph's going to be going down because you have a negative amplitude. So that A is important, not just in how fast it's going up or how wide it is, how skinny it is, but also which direction that it's headed. So pay very close attention. And again, once you can get into this equation and you get comfortable with it, you can visually see exactly what's happening, and you can get an idea before you even solve if you have actual real solutions or if you're going to have imaginary solutions just by visually being able to see what's happening. Now, if you like these videos, please like and subscribe, hit the bell button so that you get notices when a new video is added. And always pass this information on to those who it might benefit.